to volumes, so 3 dimensions. There are 1, 2, 3, 4 different techniques in finding the volume of objects. The first one I'm going to talk about, the cross-section method. I think this is in your notes. Is this in your notes?
Yes.
It is? Okay. So the cross-section method is unique because there is no axis of revolution. We're not revolving anything around an axis. Okay? So cross-section, there's no revolution. Everything else, this is a revolution, this is a revolution. The shell method is a revolution. We're not going to talk about the shell method today. We probably would have time, but I don't want to give you too much information. Information overload. So this is what we're going to talk about today. And then surface area, volume, we'll talk about that Monday also. Alright, so cross-section method. 4 easy steps. The good news is we've already done this before. Do you remember the problems 2 months ago when I said we're going to find the...
Nope.
Probably a month ago.
4.6?
Remember, I think it was it was chapter 5, where you had to integrate, you had to find the volume of something using RAM. Remember we added up, find the volume of like a hemisphere?
Yeah.
Remember that? And I said you're going to do a ton of those types of problems later on. That later on is today.
Thank you.
You're welcome.
Welcome to
Alright, so let's say I've got, well this is the x-axis, this is the y-axis, this would be the z-axis.
Oh, no.
So let's say I've got
Shenanigans.
a circle, and this top half of this circle, well, the whole circle is x squared plus y squared. How big do you want the radius to be? 7. So it's equal to 49. Okay, if I solve for, sorry, I said it first. If I solve for y would be plus or minus the square root of 49 minus x squared. Okay, so if I only worried about the top one, this graph from here to here represents the square root of 49 minus x squared, where the radius is 7. Are you with me?
Yeah.
Okay, so if I graph just the top one on 2 dimensions, it would look like that. Okay, so the entire would be the plus or minus. So let's say I have cross sections. Alright, let's say that the cross section is going to be a square.
Oh my gosh.
God, I can't do that.
Whose base is found on the circle. Okay, so imagine infinitely many squares here that are going to form a solid. So they're actually many things. Okay, so if there's a square right over here, this is what it would look like.
Those are going up on the z-axis?
Yeah.
All of their bases are all found on that circle. Can you kind of see it?
No.
So there's a whole bunch of them.
So is it going to be a cylinder then?
Well, is it a cylinder?
It's a dome.
I don't know that we have a shape for it.
Dome.
Because it's going to get really small right here.
A dome.
Kind of a...
Wait, why is...
Who's that? Like an armadillo where it stacks up high
Why
and
is
low kind
Why
of
is
thing?
the height going to be less on the edges though?
Because anybody have that answer? Why is the height going to be smaller here? Right. And what kind of shape is it? It's a square.
Square.
Okay. All right. So step 1 is to sketch the solid and a typical cross section. So I drew 3 cross sections. Kind of hard to visualize, but each shape of the cross section is going to be a square, and they do vary in how large they are. But we have it drawn. 2, find a formula for a of x. This is the big one. This is 90% of your work. Finding out what a of x is. Okay? Yeah.
Oh wait, so x and y are like this, and z is like this?
Coming up. Yep.
Oh, makes so much more sense
Good. All right. So we need to find out what a of x is. In this case, what kind of shape is the cross section? Square. Good. And how do you find the area of a square? More specifically, it's just the base squared, right? If x was a base, because it's the same, not base. Alright, so all we really have to do is find out how long this base is, square it, and we have the area of the cross section represented with a function. So how long is this base?
Why are we?
Fine.
It's X. Can you do like a midpoint thing?
It is.
2y.
Alright, I'm hearing lots of stuff.
2y.
And I'd say the best answer so far is 2y. But that still doesn't give us our answer in terms of x. But do you see that any point on this half circle, if it's y equals the square root of 49 minus x squared, each of those ordered pairs is x comma that. Isn't it? We've done those before.
Okay, so it's 249 minus
How
x
did
squared.
he get 2y?
Because this is y, which is also the square root of 49 minus x squared. And that's not the entire base, is it?
That's half the base.
That's half of it. So we need to find the whole thing, which is 2y, which is also equal to 2 square root of 49 minus x squared. Okay, so my area function is the base squared. That'd be 2 square root of 49 minus x squared. Okay,
I like this.
alright, so all we need to do is represent the area of one of the cross sections, the shape. Okay, that's step 2. Now that's the bulk of the problem. The toughest part anyway. Step 3, find the limits of integration. First of all, are we integrating with respect to x or y here?
Oh, no.
We're changing what?
Y.
With respect to x. All of our squares, or their individual little prisms, their delta is the x. So we're integrating with respect to x. So it's going to be the integral. Let's simplify our a of x. What would that be? What's my a of x simplified?
4 times 49 minus x squared.
Good enough, thank you. Okay, and if we're integrating with respect to x, we're going from here to here, so that'd be negative 4 to 4.
Whoa.
Whoa.
You mean 7?
Oh, we used 4 first though, sorry. Now how am I going to change that into a 7?
Oh.
What did you?
That looks like
Don't you
a 1
just-
now.
It's a z7.
Trade it.
Why don't you just integrate from 0 to 7 and multiply by 2?
Good.
Okay.
So 2 is done, 3 is done, integrate. Okay, so we integrate, find the antiderivative. I'm not going to talk about that. We have lots of different ways to integrate. We learned all about integration last chapter. Now we're just applying it.